In this video, we will be talking about factoring. Factoring basically means taking out the greatest common factor in an expression. Let's have an example in order to understand this more. Say 2x plus 8. To factor this binomial, we need to first get the greatest common factor and take it away from the expression. The greatest common factors of 2x and 8 would be 2, and 2x divided by 2 is x, plus 8 divided by 2 will be 4. Notice that x plus 4 is in its simplest form. That means you can no longer factor it. And that will be the answer for this expression. Let's have another one. 3x squared plus 18x. Now in getting the greatest common factor of this expression, you need to think what numbers or variables can you take away from the expression that exists in all of its terms. In this case, 3x squared and 18x. Now we know that x and some numerical value exists in both of these terms. So let's take away x. You cannot take away x squared from the equation because this term, 18x, only have one x in it, or x raised to the power of 1. So the maximum that we can take from both of this equation is a singular x. And we also have the greatest common factor of 18 and 3, which is 3. And then we divide. 3x squared divided by 3x, like right here. So 3 cancels out, and x squared divided by x is just x, because this x cancels out one of the x here, so we're left with x raised to the power of 1, or simply x, plus 18x divided by 3x, which should be 6. That will be the answer for this expression. Now let's take a look at expressions with 3 terms, or trinomials. Let's take this for example. X squared plus 6x plus 8. Now in factoring these expressions, first, we need to find the numbers that multiplies to 8 but adds up to 6. In doing that, we first need to get the factors of 8, or numbers that multiplies into 8. 1 times 8 is obviously 8. 2 times 4 is also 8. But remember that we are not only looking for numbers that multiplies to 8 but also adds up to 6. We can test this by adding 1 and 8. 1 plus 8 equals 9. So this is not correct. 2 plus 4 is 6. So this will be the factors that we will be using. We can only achieve this term by multiplying x by itself. So let's put that at the very beginning of our factor. And then we have our factors that we got, 2 and 4. Let's insert that in our answer. And that will be the final answer for this expression. Now if we want to check whether we got the correct factor, we can simply multiply both of our factors and see if we get a return to our original expression. Now we use FOIL method to multiply these two terms. X times x will be x squared, and then x times 4 will be positive 4x. 2 times x is 2x, and then 2 times 4 is 8. Add like terms. Now we get x squared plus 6x plus 8. Now this is the same with our expressions originally, so that means that we indeed got the right factors. Let's take another example. Say x squared plus 3x plus, and let's say negative 18. So same steps follow. We need to get the factors of negative 18. So notice that you have a negative value here. So that means one of the numbers that multiply to another number should have a negative sign in order to achieve negative 18. So what are the numbers that multiplies into 18. 6 and 3 multiplies to 18. 3 and 6 also multiplies to 18 and can potentially be positive 3. So all we need to do now is to figure out where we put the negative sign. You can put the negative sign at the 6 or at the 3. And now let's test it out. Negative 6 plus positive 3 will be negative 3, which is incorrect because we are looking for positive 3. Negative 3 plus positive 6, however, is positive 3. So we indeed got our middle term. So this will be the two factors of this expression. We have x minus 3 and x plus 6. That will be the final factor for this problem. What if the leading coefficient is not 1 like the past examples? So let's take for example 2x squared minus 5x minus 3. What will we do then? In cases like this, take the leading coefficient 2 and multiply it to the constant term negative 3. This should equal negative 6, and this will be the one or the number that we will be factoring or getting the multiples of. We will think of numbers that multiplies into negative 6 but adds up to negative 5x. We should be able to get 1 and negative 6. 1 times negative 6 is negative 6, and 1 plus negative 6 is negative 5. So this will be a factor. Now from here, we should write down our expression but replace negative 5x with negative 6x plus positive 1x. Now this is only valid because negative 6x plus 1x still equals negative 5x, so the value of the expression is not really changed. Now with 4 terms, you can now use a method called factor by grouping. So we first group our expression into two sets of groups, and then we take out the greatest common factor of the first group. The greatest common factor of 2x squared and 6x is simply 2x. 2x squared take away 2x is simply x, and negative 6x divided by 2x is 3. Let's do the same for our second group. Now we find out that x minus 3 or 1x minus 3 is in simplest form. So we just copy this term and then we factor out our expression. So x minus 3 is a similar term in all of these all of the terms, and then we left out with 2x and 1. 2x should go here and 1 here. That will be the answer for this expression. Remember that you can always check out if your factor is correct or not by using the FOIL method. Let's take another example here. By the way, how can we know if an expression can be factored by group? Because some expressions with 4 terms cannot be factored with this method, so you can do this to quickly check if you can actually factor this expression with factoring by grouping. So in our first group, we divide negative 6 by 2 and we get negative 3. The same goes in our second group, negative 15 divided by 5 equals negative 3. Now both these answers should be equal, so we can know that the expression can be factored by grouping. Now that we know, let's proceed to factoring the expression. So first, we need to get the greatest common factor of 2x cubed minus 6x squared. That will be 2x squared. 2x cubed divided by 2x squared is just an x. And 6x squared divided by 2x squared will be 3. Take the greatest common factor of 5x minus 15 And since 15 has no x in this, we only get the greatest common factor of 15 and 5, which should be 5, and we're left with x minus 3. We take away x minus 3 and multiply it to 2x squared and 5. That will be the final answer for this expression. Now let's factor this expression. X squared minus 25 is a binomial, which have no greatest common factor. In cases like this, we can use the sum and difference of a square formula, which goes like this. A squared minus b squared is equals to a minus b times a plus b. Now what this formula states is that if you have a binomial that is a perfect square, you should be able to get a factor that looks very similar to these terms. Now by inspection, we should be able to know that x squared minus 25 is a perfect square. So we set a squared is equals to x squared and b squared is equals to 25. The square root of a squared is simply a, and the square root of x squared is x. Meanwhile, the square root of b squared is b, and the square root of 25 is 5. Now we can use these terms and substitute them to this formula. A being x minus b, which is 5, times a, which is x, and then 5. This will be your final answer for this expression. Let's have another example. 2x squared minus 32. Now notice that 32 is not a perfect square, but we can simplify the expression by taking away 2 from both terms. So let's factor out 2 and we should be left with negative 16. There we go. X squared minus 16 is now a perfect square, which means we can use the formula in order to get the factor. A squared, which is equals to x squared, and b squared, which equals 16. The square root of a squared is equals to x, and the square root of b squared is b, and the square root of 16 is positive 4. Using the formula, we say that a plus b, which is x plus 4, times a minus b, which is x minus 4. Now the arrangement of these terms doesn't really matter because we're just multiplying them, so arrangement is not really our concerns. And there we go. And don't forget, you took away 2 from this expression a while ago, so don't forget to bring it back to your final answer. And this will be the final answer or the final factor for this expression. What about this example? X squared plus 8x plus 16. When you see a trinomial, you should know if it's a perfect square trinomial or not. And to do that, take the square root of the leading coefficient, which in this case is 1, and also the square root of the constant term, 16. The square root of 1 is just 1, and the square root of 16 is 4. Now you should multiply these two answers and you come up with 4. Now notice that 4 is just the half of the middle numerical value of your middle term, which means 8 divided by 2 is 4. Now if you meet these conditions, now you know that this expression is a perfect square trinomial. So now let's proceed to the square of binomial formula. The square of binomial formula states that a squared plus 2ab plus b squared is equals to a plus b squared. Now the other variation is we have a negative sign before the middle term. You should have a negative sign for your final factors too. But for now, since we have a positive sign before our middle term, let's discard this formula. And the next step is to set a, or so a squared is equals to x squared and b squared is equals to 16. The square root of a squared is a and the square root of x squared is x. Do the same for b and you come up with b equals 4. Simply substitute these values to these factors and we get a is x and b equals 4 squared, and we should easily get the factors for this formula or expression. Let's try another example. Say y squared minus 8y plus 16. Set a squared equals y squared and set b squared equals 16. Square root of a squared is a and the square root of y squared is y. Do the same for these terms, for this value, and you get b equals 4. Now since we have a negative sign for our before our middle value, we should use this counterpart of the binomial formula, which is like this, and simply substitute our values to these factors, a being y and b being 4 squared. Let's try this example. Notice that the expression is a perfect cube. If you are factoring two terms like this and they are both a perfect cube, you can use the sum of cubes formula, which goes like this. A cube plus b cube is equals to a plus b times a squared minus ab plus b squared. Now we can already see that these terms already look similar, so we set a cube to be x cubed and b cubed to be 64. The cube root of a cube is a and the cube root of x cubed is x. Now the cube root of 64 is simply 4. Now all that's left to do is to substitute these values to this formula. We should be able to get a equals x and b equals 4. A squared is just x squared minus a times b is 4 times x. That should be 4x plus b squared, which is just 4 squared, and which is equal to 16. That will be your final answer for this expression. Let's jump into another example. Say 8x cubed minus 27. So here, they are still perfect cubes, but we have a negative or a minus sign in between them. And that means we should be able to use the difference of cubes formula instead of the sum of cubes. The difference of those two formulas is just really the sign between the terms that you are factoring. So if you see negative, you use the difference of cubes, and if you see positive, you use the sum of cubes. So in this problem or in this equation, we are using difference of cubes, which goes like this. Now let's set a cube as 8x cubed and b cubed as 27. The cube root of 8 is 2 and the cube root of x cubed is simply x. Now the cube root of 27 is 3, and now all that's left to do is the same as before. Substitute these values to the formula. A minus b, which is 2x minus 3, and then a squared is just 2x squared, that's just 4x squared, and ab or a times b is just equal to 2x times 3, which is 6x, plus b squared or 3 squared will be equal to 9. This will be our answer for this equation.